The universe is made of stuff we can barely begin to imagine. The universe is made of things we can hardly imagine. Dark matter, energy, and other mysterious forces comprise the maximum mass in the universe. It is difficult to grasp what is out there and how it works. It is so mysterious and unfathomable that we haven't even examined it thoroughly. An equally unsurprising fact is that we can't see much matter even if it exists under our noses. It may be invisible, but it's pretty real. Even though scientists don't know what dark matter is, they understand that it is essential to how galaxies form. On the other hand, dark matter can't be seen because it doesn't deliver any light. Scientists know it's out there though, because there is something in galaxies that can't be seen with the naked eye or with scientific equipment. So, what is this mysterious thing in space that scientists call dark matter? And why are they trying so hard to figure it out? Dark matter is a mysterious, invisible substance that is nearly never found except by its gravitational pull. However, scientists say it probably makes up a quarter of the universe and outnumbers the percentage of normal matter out there in space, such as galaxies, stars, and planets. We don't really understand what makes up the whole universe. This might be a surprise to you. But don't worry, an Oxford scientist has come up with a new concept that may solve one of the biggest mysteries in the universe. Scientists have long thought that the universe was growing, but this growth would slow down at some point. When NASA's Hubble telescope began looking into space, it saw something strange. The universe wasn't slowing down. Instead, it grew larger quickly. It didn't make sense, and astronomers couldn't figure out why. They struggled with a few different ideas, but have mostly decided on this one. Dark matter and dark energy make up 95% of the universe. Scientists can't see these two things, but they know they happen because of how they affect things that can be seen. Astrophysicist Jimmy Farms at Oxford University suggests that dark matter and dark energy might operate together as a dark fluid of negative masses. Dark matter and dark energy were thought to be two different things until now. The fluid would have negative gravity, which means that instead of pulling things towards it, it would push them apart. It's a strange idea, but it's not a new thing. A theory printed in scientific paper Astronomy and Astrophysics aids in explaining some strange things about the universe. For one, galaxies spin so rapidly they should break apart. But it appears that a halo of dark matter keeps this from happening. The new theory also says that a dark fluid with a negative mass may end up causing these halos to establish. But the negative matter is an issue because it indicates that dark energy would get less dense over time. But findings imply that this isn't the case, and dark energy stays mostly the same. So, according to the theory of the origin of matter, the concept is that a growing amount of stuff keeps popping up and taking the place of the negative matter that goes away. Even though space-time is empty, more negative masses keep popping into existence, making it seem like popcorn. Garrett Lewis, an astrophysics professor at the University of Sydney, said, "There are a lot of tests that we need to do first before we can say that this is similar to what we know today. Then, we need to figure out what estimates this model makes that the existing cosmological models fail to do." So, one of the most important things that will have to be fixed is the problem with the negative mass. Lewis says that we do not really know the nitty-gritty details of how something like this could actually occur. We can jot down equations for different things, but until we explore and test the universe, we won't know if those equations are valid or not. He said that more research is needed, and that research is already being done at places like CERN, the European Organization for Nuclear Research, to look into the possibility of negative masses. The Square Kilometer Array, which, when finished, will be the most giant radio telescope in the world, is another project that could help. Lewis said, "In a sense, we have to always be trying to push the frontier of fundamental physics, because every time we explore a new area, it seems strange and esoteric at first, but it ultimately makes its way into our daily lives." In addition to these theories, researchers have developed another strong case. Atoms made up of protons, neutrons, and electrons make up everything we see in the universe, including Earth, the Sun, other stars, and galaxies. Normal or baryonic matter makes up less than 5% of the universe's mass. This may be one of the most surprising things learned in the 20th century. On the contrary, the rest of the universe seems to be made up of mysterious, invisible substance called dark matter, and a force called dark energy that works against gravity. So, as we already said, scientists still haven't seen dark matter directly. Dark matter doesn't interact with baryonic matter. Light and other forms of electromagnetic radiation can't see it. This makes it impossible to find with the tools we have now. But scientists are sure it exists, since it seems to have gravitational effects on galaxies and groups of galaxies. For example, standard physics says that stars at the boundary of a spinning spiral galaxy should move much lower than stars near the galaxy center, where most of the visible matter is. But research shows that stars move around the galactic disk at about the same speed no matter where they are. This strange result makes sense if you suppose that the boundary stars are experiencing the gravitational effects of dark matter and the halo all around the galaxy. Dark matter can also clarify some optical illusions that scientists observe in the universe. For example, strange rings and arcs of light in pictures of galaxies could be understood if the light from even further galaxies is modified and amplified by huge, invisible clouds of dark matter in the foreground. This is called gravitational lensing. So, scientists have some ideas about what dark matter can be. One popular idea is that dark matter is made up of mysterious particles that don't deal with normal matter or light, but still have gravitational effects. Some scientists think that the impacts of dark matter could be explained by making big alterations to how we think about gravity. According to these ideas, there are different kinds of gravity, and the gravity that controls galaxies differs from the gravity we're used to. Dark energy is even stranger, and scientists were shocked when they found out about it in the 1990s. As we have discussed before, physicists thought that the attractive force of gravity would slow off the universe expansion over time. To prove this further, two independent teams attempted to determine the rate of deceleration and found that the findings of the previous studies were correct because expansion was accelerating. One scientist said it was like throwing a set of keys up in the air and hoping them to fall back down, only to see them fly upward toward the ceiling. Scientists now think that the rapid expansion of the universe is caused by a force that pushes things away. This force is generated by quantum fluctuations in otherwise blank space, and it seems to get stronger as the universe grows. Many scientists have also highlighted that the known characteristics of dark energy fit with a cosmological constant, a mathematical fix that Albert Einstein connected to his theory of general relativity to make the equations fit with the idea of a static universe. Einstein said that the constant would be a force that pushes against gravity and keeps the universe from falling apart. Later, when astronomical studies showed that the universe was expanding, Einstein gave up on the idea, labeling the cosmological constant his biggest mistake. So, now that we can see that the expansion of the universe is speeding up, adding dark energy as a cosmological constant could almost explain how the space-time is being spread apart. But that still doesn't tell scientists why the mysterious force is there in the first place. So, that's it for now. I hope this video was informative as always. If you like this video, smash the subscribe button for more future updates. Thank you for watching.